So I just got back your first Algebra 2 test since we've been stuck at home. It's not the end of the world. I've actually been very impressed with the results. This was actually a really, really good test. So now I want to apply some of the things that we learned in the previous unit, like the rational exponents, the radicals, the nth roots, and it's all coming together for this Algebra 2 pre-calc blurred area. The idea in chapter 6.6 is we're solving radical equations, and the goal is we're back to solving for x, but the only difference is there's going to be some radicals and rational exponents. So I know you're going to hear the same old story, but it's the same thing, and you're going to thank me for that table. So go back to chapter 3 when we did solve for x, and I had my college professor from the spring of 2012, the last math class I ever took was abstract algebra. Research it, it is intense. If you've ever seen a Futurama episode called The Future of Benda, that is exactly what I had to study. Just look it up, Future of Benda, B-E-N-D-A. Anyway, so my college professor said, if you can get barefoot, you can do algebra. We just looked at each other like, what are you talking about, man? He said, algebra is as simple as shoes and socks. You put on the sock, you put on the shoe, you take off the shoe, you take off the sock. And it's the same thing. So let's just say you have layers upon x. Ogres are like cakes. No, I'm just kidding. No, ogres are like onions. They have layers. So there's layers of x. Let's just say you have 1, 2, 3, 4, 5 layers upon x. You can't just take them off 1, 2, 3, 4, 5. You have to go in the opposite direction. You have to take off layer number 5. You have to take off layer number 4. You have to take off layer number 3, layer number 4, layer number 5. So the order goes around. You have to take off the layers from outermost layer to innermost layer, and that is it. Okay, so let's get some problems in. We're going to do 6 problems today since I know it's Friday and y'all are working for the weekend. Okay, so take a look at problem number 1. So I start off with something very, very easy. Solve the equation, check your work. When I see that x, I'm going to put a big old target on it. I'm going to rewrite the problem, but I'm going to put a big old target on my x to start the problem. That's just how I do it. So this is a pretty simple one. So the first thing I look at in my target is what is the first layer being applied to x? So that would be the square root, but we're not done. Once we've square rooted x, the second thing, what's the second thing being done to x? We are going to minus 5 on both sides. We're going to minus that layer with 5. And that's it on that side. So now we're going to undo the layers of x. So we start from the bottom, and you can finish the rest of that song. So minus 5 has to be undone with the inverse operation, plus 5. Then the square root, what is the inverse of square root? We're going to square both sides. So we're going to start with plus 5, then we're going to square. We have a plan, let's stick to the plan. So looking at my layers, I'm going to undo both sides by adding 5 to both sides of the equation. Minus 5 and plus 5 get knocked out. So I'm left with the square root of x is equal to 8. Now, once I've cleared the plus 5 layer, how do I clear the square root layer? I'm going to square both sides. So that leaves me with both sides of the equation getting squared. And that leaves me with x is equal to, what is 8 squared? That would be Nintendo 64. So check your work, and you're going to thank me later because there's this thing where there is no solution, and we'll get to those probably next week. So I'm going to plug in. I'm going to check my work by plugging in x equals Nintendo 64. So I've got the square root of Nintendo 64, and that's going to be 8. Minus 5 is going to be 3. And that's what we wanted all along. Okay, problem number 2 is a little bit different. Once again, square root of x plus 25 is equal to 4. So when I see an x and all these radicals and rational exponents, I'm going to put a big old target on x. So I'm going to rewrite the problem because I'm going to use that target in the first part. Okay, so I'm going to look at my x. What is the first thing bothering my x? It's actually going to be plus 25. And then it's going to get square rooted. So I've got 2 layers upon my x. I've got plus 25 is, let's just call it the sock layer, and then that square root is going to be the shoe layer. So I'm going to undo the layers of x as such. Start from the bottom, sing that song. So the square root gets to be undone by squaring both sides. Plus 25 gets to be undone by minus 25 on both sides. We have a plan. Boom, boom. Let's stick to the plan. So the first thing I need to do is square both sides. And that gets me, and squaring the square root knocks out the square root, leaving me with just x plus 25 is equal to, well, what's 4 squared? That would be 16. So now I've got x plus 25 is equal to 16. I'm going to undo the plus 25 with the minus 25 layer. So I'm going to minus 25 on both sides, getting me x is equal to 16 minus 25, which should be negative 9. But wait, I don't believe you. Let's check our work. So I'm going to check my work by plugging in x equals negative 9. So my original problem is blank plus 25, but the blank is going to be negative 9. Well, negative 9 plus 25 is 16, so we've got the square root of 16, and the square root of 16 is 4. That's what we wanted all along. Moving on. We've got, this one's a bit tricky. The square root of the quantity of 3x plus 10. That whole thing is in the square root. So I'm going to put a big old target on the x, and I'm going to analyze all the layers on my x. So we've got the square root of 3x plus 10. Now, again, if the layers and undoing table helps you, like it did me when I was in high school, I actually learned this technique when I was in college, and then I applied it to when I used to student teach at a public school. So I've been using this for a long, long time. But you don't have to use the layers and undoing method if you can do this at the snap of the fingers. So I'm going to look at the layers. I'm going to look at that target that I set up. What is the first thing bothering my x? So the first thing bothering my x is times 3. What's the second thing bothering my x? Plus 10. And then there's a third layer, and that happens to be the square root. So I'm going to undo the layers of x. This time I've got 3 layers bothering my x, and I got to go in a specific order. Kind of reminds me of my fashion choices when I was in college. Short sleeve shirt under long sleeve shirt under short sleeve shirt. So let's undo the layers. So I'm going to undo from the bottom to the top. How do I undo the square root? I'm going to square both sides. How do I undo plus 10? I'm going to minus 10 on both sides. And then how do I undo times 3? I'm going to divide by 3. So according to my plan of attack, I need to square both sides first, minus 10 on both sides second, and then divide by 3 on both sides for the last step. Let's stick to the plan. So, first things first, I'm going to square both sides. The square and the square root are inverse operations, so they cancel out, leaving me with 3x plus 10 is equal to Nintendo 64. So I get 3x plus 10 is equal to 64. I'm going to undo the next layer by minusing 10 on both sides. So then I get 3x is equal to 64 minus 10, which is 54. Once I've cleared that, I need to do the last step, which is divide by 3 on both sides. So I get 3x equals 54. I'm going to divide both sides of the equation by 3. 54 divided by 3, I believe, is 18. So x is equal to 18. I just counted backwards from 60. 3 times 20 is 60, and I counted backwards. 57 would be 19, and 54 would be 18. So I'm going to check my work because I'm always careful. X equals 18. I'm going to plug it back in. So I'm going to check my work 3 times. I'm going to get a calculator. I just leaned over. Sorry about the roller coaster there. 3 times 18 is 54. 54 plus 10. 54 plus 10 is 64, and the square root of Nintendo 64 would be 8, and that's what we wanted all along. Okay. See if you can do this problem independently. You can pause the video. Okay, so I'm going to put a big old target on X. This one's a little bit different, but if you've got the hang of this layers and undoing table, it's a piece of cake. And cakes have layers too. The square root of 9x plus 11 is equal to 14. What is the first thing bothering my x? The first thing bothering the x is the times 9 layer. So the first thing I'm going to put is times 9. What is the second thing bothering my x after times 9? The square root. And then after that, that whole thing gets added 11 on both sides. On the layers of x. And that's it. So now I wear short sleeve shirts under long sleeve shirts under short sleeve shirts. So I'm going to undo the layers of x in a very specific order. The outermost layer to the innermost layer. I'm going to undo plus 11 by minus 11 on both sides. I'm going to undo the square root by squaring both sides. And I'm going to undo the times 9 layer by dividing both sides by 9. Now, we've got a plan. Let's stick to the plan. I'm going to zoom out so you guys can see. So, according to my plan, I got a minus 11 on both sides. So now, I've got the square root of 9x is equal to 3. Now, what do I need to do? Well, I've cleared this layer, the minus 11 layer, so I need to square both sides. Let me square both sides. So that leaves me with the square root and the square knock each other out, so I'm left with just 9x, but then 3 squared is 9. So I've cleared that layer, and now I need to do one more thing, and that is divide both sides by 9. And x is equal to 1. And if you check your work, so I'm going to check with x equals 1. So 9 times 1 is 9. So I still have the square root of 9 plus 11. The square root of 9 is 3. I'm still going to add 11. And that gets me 14, which is what I wanted all along. Okay, 2 more problems and then we'll call it a day. Well, if you want to do these problems independently, be my guest. Let me close that up so anyway, that blue line's not supposed to be there. See if you can do these problems independently. Okay, so once again, if you don't like the layers and undoing and you just want to do your own thing and you still get the right answer, be my guest. Personally, I kind of struggled with teaching this, so the layers and undoing was the perfect analogy to help students who struggled with solving for x. So let's get on with it. What are the layers upon my x? Well, the first layer I can think of is x is being subtracted by 25. So we've got the first thing we put on the x is minus 25. The second layer we can think of, the second layer after x minus 25 is it gets square rooted. The third layer after that, x, then minus 25, square rooted, plus 3. So I'm going to undo all 3 layers. First things first, I'm going to subtract 3 from both sides. Then I'm going to square both sides. Then I'm going to plus 25 on both sides. So we've got a plan. Minus 3 on both sides, then square both sides, then plus 25 on both sides. Let's get rolling. So I've got the square root of x minus 25 plus 3 is equal to 5. So I'm going to subtract 3 from both sides. That gets me the square root of x minus 25 is equal to 2. I've cleared this layer. Now what do I need to do? I'm going to square both sides now. So let's square both sides. So now I've got the square root of the square root and the square knock each other out. So I've got x minus 25 equals 4. Cleared that. Now I'm going to add 25 on both sides. So that gets me x is equal to 29. Okay, we're going to check our work. I'm running out of space, so I'm going to do this on the side. So the square root of x minus 25 plus 3. So if I plug in 29, I get 29 minus 25, which is 4. So the square root of 4 plus 3. The square root of 4 is 2. 2 plus 3 is what we wanted all along, which is the output of 5. Okay. Over here now, this is a bit of a mystery. Okay. So now I've got 8 times the square root of 10x minus 7 equals 9. So I'm going to make a target on my x, and I'm going to apply the layers and undoing table. Another fun while I write this layers and undo, not only do I think of my college professor from my last semester as an undergraduate student, but I also think about summer school. I think it was like 3 years ago. There was a particular student, I actually had him for summer school for geometry, and then the following summer I had him for summer school for algebra 2. And he just hated math, and what's funny is when I had him for geometry, he was just angry, I hate this math, and then for algebra 2, I had him the next summer, and he went yes, and so on the day of the final exam, he got I can't remember the exact score, but it was like a really great, like high B plus or a low A minus. But this was his favorite part of the unit because he hated this when he took this in Algebra 2. And he did. I'm holding the iPad with my left hand, but he basically did the equivalent of like this like cannon celebration where he just pumped his fists on both sides like cannons. Just it's like one of the funniest things. Anyway, so let's do this last problem really quick. Anyway, so we've got x, and the first thing bothering my x is times 10. After that, x times 10 gets square rooted. Then x times 10 gets square rooted. That gets multiplied by 8. Oh, I thought there was only 3 layers. And then after that, x gets multiplied by 10, then square rooted, then multiplied by 8, and then subtracted by 7. 4 layers. Let's undo the layers upon x. All right, here we go. Step 1, step 2, step 3, step 4. All right, step 1. How do I undo minus 7? Oh, come on, focus. I'm a little bit. So I'm going to subtract 7 by, undo that by adding 7 on both sides. Then divide by 8. Then square both sides. Then divide by 10. Yes! So let's undo the layers. So 8 square root of 10x minus 7 equals 9. I'm going to add 7 on both sides of the equation. So then I get 8 square root of 10x. Remember that 10x is in the radical itself. So 9 plus 7 is equal to 16. 8 radical 10x is equal to 16. Divide both sides by 8. So then we get the square root of 10x. 16 divided by 8 is 2. And now I've got the square root of 10x is equal to 2. Once again, I've cleared the plus 7 layer. I've cleared the divide by 8 layer. Now I'm going to do the squaring on both sides layer. So let's square both sides. So then I'm going to get square root getting squared, that's 10x, and you're going to see this every once in a while. 10x is equal to 4, right? When 10x is equal to 4, we're going to divide both sides by 10, and you're going to get a fraction. So I get, first off, if you like decimals, that's all right with me, 0.4. Or if you want to leave this as a simplified fraction, 4/10 can be reduced by dividing the top and bottom by 2. Please leave as a simplified fraction. Pick one or the other. If the decimal ends, write it. If the decimal repeats, put a hat on the repeating part. Or if you like fractions, I'm okay with that too. Once again, I'm not a hypocrite. I like to check my work because when it's a fraction, you never know. So I've got 0.4 goes in for x. 10 times 0.4 is 4, so 8 radical 4 minus 7. 8 times the square root of 4 is, we've got 8 times 2 minus 7. 16 minus 7 is 9. Happy birthday to the radical. That's what we wanted all along. We're going to do harder examples with this. We're going to have cube roots, maybe fourth roots, maybe a fraction in the exponent, like 3/2 power, and how to undo that. Hope you guys have a great weekend. I will see you guys. Oh, by the way, we have a new schedule to incorporate more social time. So our math class is going to be Mondays, Thursdays, and Fridays. So no Tuesdays or Wednesdays. It'll be Mondays, Thursdays, and Fridays. They changed the schedule a little bit. I think the times is still the same, but for now, plan on Mondays, Thursdays, and Fridays at 11 a.m. Have a great weekend.